Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. Access control is at the heart of cybersecurity. It determines who gets access to what and under what conditions. In our last episode, we looked at mandatory access control and discretionary access control. Today, we continue that conversation by exploring three more access control models that are widely used in business, enterprise, and cloud environments: role-based access control, rule-based access control, and attribute-based access control. These models offer flexibility, scalability, and the ability to match permissions to real-world job responsibilities. Let's start with role-based access control, often abbreviated as RBAC. In this model, access decisions are made based on the user's role within the organization. Each role comes with a defined set of permissions, and users are assigned to roles based on their job function. Rather than assigning individual permissions to each user, administrators grant access to roles, and users inherit those permissions by being assigned to the appropriate role. RBAC is one of the most commonly used models in enterprise environments. It simplifies permission management, reduces administrative overhead, and supports the principle of least privilege. When implemented correctly, it also improves auditability and compliance by providing a clear structure for who can access what and why. Let's walk through a real-world example. A hospital uses RBAC to manage access to its electronic health record system. Doctors are assigned the physician role, which grants them full access to patient charts, medication records, and diagnostic tools. Nurses are assigned a nursing role, which allows them to update vital signs, administer medications, and view patient notes. Administrative staff are assigned a front desk role, giving them access to scheduling and insurance information but not clinical records. If an employee changes jobs from nurse to administrator, their role is updated and their access changes automatically. There's no need to manually adjust dozens of individual permissions. RBAC is especially useful in large organizations with high user turnover or frequent role changes. By tying access to roles rather than individuals, security teams can maintain consistency, reduce errors, and streamline onboarding. However, role-based access control requires planning. Roles must be clearly defined, permissions must be mapped accurately, and processes must exist for assigning and reviewing roles. If roles are too broad or overlap too much, users may end up with more access than they need. That's why it's important to periodically audit role definitions, review group memberships, and look for signs of privilege creep where users accumulate permissions over time that are no longer necessary. Now let's turn to rule-based access control. This model controls access using system-enforced rules rather than user-drawn settings. In rule-based access control, the rules are often based on conditions such as time of day, network location, device security status, or system load. These rules are defined by administrators and automatically enforced by the system. Unlike role-based access control, which is centered around the user's job function, rule-based access control focuses on context. For example, a rule might state that contractors can only access the network between 8 a.m. and 6 p.m., or that access to sensitive data is only allowed from corporate managed devices. These types of rules are especially useful in dynamic environments where access needs to change depending on risk, policy, or operational status. Let's explore a scenario. A financial institution uses rule-based access control to protect its trading systems. Employees are allowed access only during market hours and only from the company's secure network. If someone tries to connect outside of those hours or from an unapproved network, access is denied, even if the user has the right credentials. This adds a layer of protection based on business logic, not just identity. Rule-based access control is often implemented as part of a broader policy engine or security platform. It works well in environments where you need to enforce conditions and contexts, but it doesn't always account for detailed user attributes. That's where attribute-based access control comes in. Attribute-based access control, or ABAC, is the most flexible and granular of the access control models. In ABAC, access decisions are made based on attributes associated with the user, the resource, the environment, and the action being taken. These attributes are evaluated against policies to determine whether access should be granted. Attributes can include anything from job title, department, and clearance level to time of access, location, device type, or sensitivity of the data. A BAC allows for highly dynamic and adaptive access control policies that reflect real-world conditions and risk levels. Let's walk through a practical example. A government agency uses attribute-based access control to protect its case management system. A policy is created that allows access to case files only if the user is assigned to the case, has the required clearance level, and is accessing from a government-issued device. The user's attributes, the case file's classification, and the device's compliance status are all evaluated in real time. If all conditions are met, access is granted. If any condition fails, such as logging in from an unapproved device, the request is denied. ABAC is particularly valuable in cloud environments, where users, devices, and data are distributed across different systems and networks. It supports zero-trust architectures by allowing organizations to define and enforce complex access policies that go beyond traditional roles and groups. The benefits of attribute-based access control include increased flexibility, better support for granular policy enforcement, and the ability to adapt to changing environments and threat levels. However, ABAC also requires robust identity and policy management systems. It demands accurate and up-to-date attribute data, clearly defined policies, and strong integration with identity providers and enforcement points. One of the challenges with ABAC is complexity. Policies can become difficult to manage as the number of attributes grows. To address this, organizations often use policy authoring tools or policy as code frameworks that allow for version control, testing, and collaboration across teams. To summarize, access control models provide different ways to manage and enforce who can access what. Role-based access control uses predefined roles to group permissions and assign them to users, making it easier to manage access at scale. Role-based access control uses system-enforced conditions to control access based on context like time, location, or device state. Attribute-based access control evaluates user, resource, and environment attributes in real time to make fine-grained dynamic access decisions. Each model has its strengths, and many organizations use a combination of all three to strike the right balance between security, usability, and flexibility. For the Security Plus exam, expect to answer questions about the differences between role-based, and attribute-based access control. Be able to match each model to its strengths, identify the scenarios where each is best used, and understand their limitations. You may be given a scenario where users need time-based or location-based access, or where fine-grained conditions must be enforced. Review terms like access policy, role inheritance, context-aware access, access attributes, and policy evaluation. They're all important and likely to appear. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.